Okay, so this is the group problem solving 2 for the chapter 4. So we speak about moment, the section 7, so simplification of a system of force and couple. So on this pipe, we have a force F1, a force F2 there, and a force F3. So we have a system with 3 forces in 3 different directions, and we also have 2 couples. Oops. This one, oh, I need to redraw my F1, that I will call C1, and this one that I will call C2. C2. Okay, so 3 forces, 2 couples. It's a 3D system, so we can replace it by only one force is 1 moment. Poof. So that's not what I want to do, but let's underline. That's not what I plan to do. Oops. I just plan to do a little line there. Oh my god, catastrophe. Here we go. Okay, just need space, so that's why. Okay, section 7. Okay, so first things to do, let's find the resultant force Fr, and Fr is equal to F1 plus F2 plus F3. Okay, so, oops, I'm sorry, that's so, let's take 1 minute for that. Here we go. F1. Okay, so we need to write those 3 vectors in Cartesian notation form to add them together. So this is I hat, J hat, and K hat. That's the 3 units vector of x, y, and z. So F1 is parallel to K, and it's going up, so same direction, so plus 300 K hat. It's going up and parallel to K. F2, so F2, so this F2, so this parallel to x, this is parallel to z. So F2, it's in a plane parallel to x and z. X and z, parallel to x and z. Let's call that x prime, z prime. Okay. This F2, so this is angle 45. So we have F2 on x and going down F2 on z because it's a plane x and z. Okay. So for x, it's in the same direction. So plus magnitude of F2, 200. Can you still see? It's 200 there. And at the adjacent side, so cosine 45 degrees on I hat. Now for the z complement, it's going down, so it's at the opposite direction of k, so minus 200. It's magnitude of F2, and at the opposite side of the angle 45, this one, or this one, so sine 45 degrees. I know for 45 that's the same, but I like to be consistent with my cosine and my sine, and it's on k. So F2 it's equal to cosine 45, it's square root of 2 divided by 2. So it means that it's 100 square root of 2 on I hat minus 100 square root of 2 on k hat. Okay, cosine 45 is equal to square root of 2 divided by 2. So 200 divided by 2, just square root of 2. And F3, it's aligned with y. So it's 100 j hat. Okay, so that's my F1, that's my F3, and that's my F2, this one. So let's add them together to find FR. So FR is equal to, so on I hat, I have just 100 square root of 2 on I hat. On J, I just have plus 100 on J hat, and on K, I have plus 300 minus 100 square root of 2 on k hat. Okay, let's write the numbers. So 100 square root of 2. Here we go. 141.4 I hat plus 100 on j hat, and 300 minus 41.4 square root of 2 is equal to plus 158.6 on k hat, and everything is Newton, right? And now we want to replace by only one couple, as if we write these forces at A. Okay, so let me write that. So Fr, let me clean this a little bit. I will draw it in red. What we found is that Fr is equal to 151.4 on I, 100 on J, so it's this one, and 158 on K, so 158.7 on K, so that's 158. So there, so finally the force Fr is this one. Okay, so if we want to replace by the force Fr and a couple, and the couple that we are looking at, which color can I take? Let me do it in gold. So we will have a couple about X, a couple about Y. How I did that? Here we go. A couple about Y and a couple about Z. Okay, so we want to replace all the system by one force Fr at O, and the couple, one couple, but there's three components, Cx, Cy, and Cz, or three, or a moment. We can call that a moment or a couple. Okay, so what we will say, let me, I want to see this. Okay, here we go. We will use our equations. So we will say on the left, then the, okay, so the couple, the moment created by the couple C, if you want, plus the moment, I'm sorry, I do that with my wrist. So plus the moment of Fr about the point O, but Fr is on O, so it will be 0. It's equal to all the sum of all, so it's equal to the moment of F1, the moment of F1 about O, plus the moment of F2 about O, plus the moment of F3 about O, plus the couple 1, plus the couple 2, plus the couple 3. There's just 2, sorry. So we want to replace everything there by only one force and one moment. But this force, because it's applied to O, doesn't create any moment at all. Okay? So basically what we want to find is the couple and the three complements, Cx, Cy, and Cz. So let's find each moment and each couple. Maybe the easier is C1 and C2. So C1, and we will write them, it's vector in Cartesian notation form, all of them. So C1, the rotation is about K, and it's 100 on K, and the question is it plus or minus? So if you step there and you look inside, the rotation is, or that's a rule of the right hand too. The rotation, so the right hand, the rules of the right hand, it means your thumb is your black axis in the middle, and your hand is rotating in the same direction as C1, so it's plus. Okay. C2 So same thing. So now C2, this is your thumb, okay? And your right hand is rotating in the plus directions. Okay, this is the plus directions there. And this C2, we need to split it on two axes. On axis, like F2. So on axis, it will be C2, that is 180, cosine 45 on I hat, and also on Z, so minus 180, sine 45 on K hat. Oh my God, what's happened? Did you see that? It disappeared and come back. Okay, so C2, it's equal, so cosine 45, sine 45 square root of 2 divided by 2, it's equal to 90 square root of 2. I add minus 90 square root of 2. K at, it's a K. Okay, don't write J, it's a K. Oh, that's for C1, so we find C1. C1, that's my orange couple. And this one, I drew it originally in purple. That's my C2 couple. Okay, now the couple of each forces. So F1 in 3D, let's take the vector analysis. So the moment of F1 about O, it's equal to R O to, so F1 is there, at the red one. So we can slide it up to A. So that's ROA cross F1. So the moment of F1 about the point O, it's equal to ROA. Let me clean this a little bit. Equals 0.5 on I hat, on J hat, cross F1, that is 300 on K hat. So the moment of F1 about O, it's equal to 150 and J cross K plus I hat. So let's draw our little I, J, K, I cross J, J cross K, K cross I, it's plus, and I, J, K, going in the negative directions, will be minus. So I cross K equal minus J, J cross I equal minus K, and J cross I equal minus K. I already said that. And I cross K equal minus J, and K cross J equal minus I. Draw those little on the piece of paper, on a cheating sheet, anywhere you want. Okay. So that's F1. So that's created by the red force. Okay. I add the moment of F2 about O, it's equal to R O. So F2, where is F2? F2 is the blue one there. Oops, that's the blue one there. Okay, we can slide it up to B because we can slide the force on its line of action and it doesn't change anything. So OB cross F2. So the moment of F2 about O, it's equal to ROB, equal to 1.1. So that's the distance from O to B on J hat cross F2. We have F2 there. So 100 square root of 2 I hat minus 100 square root of 2. Sorry, too late. Square root of 2 K hat. I took it there, F2. Okay, so the moment of F2 about O, it's equal to J cross I. J cross I minus K. So minus 110 square root of 2 on K. And J cross K is plus, so minus 110 square root of 2 on I hat. So that's the moment created by the force 2. So created by this one at O. And we want to find the moment of F3 about the point O. That's a little bit long when we use 3D and vectors, but just one step at a time. So F3, so R, O, what do you think about that? F3 is going through the point O. So is there any distance between F3 and O? No, so 0. The force F3 doesn't create any moment about O. Okay, so let's come back on our equation, this one. We have the moment about C that is equal to moment about F1, F2 plus C1 plus C2. So F1, 150 I at, F2 minus 110 square root of 2 K at minus, let me see, yes, minus is correct. Square root of 2 on I at, so that's F1, F2, F3 is 0, C1 is plus 100 on K at, and C2 is plus 90 square root of 2 on I at, and minus 90 square root of 2 on K at. So the couple, it's equal to, on I at, we have 150 minus 100 square root of 2 plus 90 square root of 2 on I at. On J, there's no rotation on J. Oh yeah, that makes sense because all the forces are going through the axis J, so they don't create any rotation on J. And plus, so for K, minus 100 square root of 2 plus 100 minus 90 square root of 2 on K at. So MC, let's take my calculator, 150 minus 100 square root of 2 plus 90 square root of 2. So it's 122 on I at and minus 110 square root of 2 plus 100 and minus 90 square root of 2 minus 183 on K at. Okay, so we can replace the three forces and two couples by one 3D forces and one couple. This couple, it doesn't apply anywhere. It's just a free vector. Okay, so we need to add this moment if the location of the force Fr is at the point O. And that's it for the chapter 4, section 7. That was the last problem. See you for the next section. Bye bye.